కొంచెం లైట్ ఇట్లా ఇట్లా. Now is it okay నమ్మా?
No, no, sir.
How is it? బోర్డు కనపడుతుంది. చెప్పండి, త్వరగా చెప్పాలి.
క్లారిటీ లేదు సార్, ఇందాకట్లానే కనిపిస్తుంది సార్.
బోర్డుకి లైట్స్ తగిలిస్తుంది సార్. కొంచెం ఫోన్ లెఫ్ట్ సైడ్ పెట్టండి సార్. అతను
ఎట్లా 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 చెప్పండి.
సార్
అంటే
బోర్డు
ఎక్కువ
కనిపిస్తుంది
బ్రైట్నెస్
బట్
ఎక్కువ ఉన్నదా తక్కువ ఉన్నదా?
క్లారిటీ మిస్ అవుతుంది సార్. వర్డ్స్ క్లారిటీగా కనిపించట్లేదు.
వాయిసా లేకపోతే బోర్డా?
లైట్
సార్
తగిలేస్తుంది సార్ బోర్డుకి.
వర్డ్స్ సార్ వర్డ్స్.
అమ్మా క్లారిటీ ఏది మిస్ అవుతుంది, వాయిసా బోర్డా?
బోర్డు
బోర్డు సార్.
బోర్డు.
బ్లర్ గా కనిపిస్తుంది సార్.
లైట్ తగ్గించమంటారా పెంచమంటారా?
తగ్గించండి సార్.
కొంచెం వెనక తీసుకెళ్తా. అడదిప్పు అడదిప్పు అడదిప్పు, అది పోదు. Now is it okay నమ్మా? ఇది
ఓకే సార్ ఓకే.
Is it okay now?
No sir. Sir, now
Yes please, is it okay?
సార్ మీరు అక్కడ నిలిచినప్పుడు క్లారిటీ ఉంచండి. మళ్ళీ మీరు ఎగ్జాంపుల్ పోయింది.
అమ్మా చెప్పాలి, క్లియర్ గా చెప్పాలి.
సార్ మీరు నిలిచినప్పుడు క్లారిటీ ఉంచండి.
అమ్మా
మీరు లెఫ్ట్ సైడ్ నిలిచినప్పుడు క్లారిటీ ఉంది సార్. మళ్ళీ మీరు వచ్చేసరికి లైట్ పెట్టి తగిలేస్తుంది సార్. సార్ ఓకే సార్, somewhat better.
Is it okay now?
Yeah sir, somewhat better sir.
ఎస్ సార్.
క్లియర్ గా ఉంది సార్ ఇప్పుడు.
అమ్మా
సార్ ఇప్పుడు క్లియర్ గా ఉంది సార్.
అమ్మా ఇప్పుడు బాగుందా?
ఇప్పుడు బాగుంది సార్.
ఓకే.
Yes sir.
Okay, note down a problem in independent events. Write down, make it quick. A problem in mechanics. A problem in mechanics. A problem in mechanics has given to 3 students. Has given to 3 students. 3 students. A, B, C. A comma B comma C. A can solve it. A can solve it with a probability of 1/2. B can solve it with a probability of 1/3. With a probability of 1/3. And C can solve it. C can solve it with a probability of 1/4. C can solve it with a probability of 1/4. What is the probability? What is the probability? What is the probability that at least one can solve the problem? What is the probability that at least one can solve the problem? Madam, Karthik పంపించి రూపీ పంపించండి. కార్తిక్ని what is the probability that one can solve the problem? Yes, I will repeat. I'll repeat. A problem in mechanics is given to 3 students. A problem in mechanics given to 3 students. Given to 3 students. A, B, C. A, B, C. A can solve it with a probability of 1/2. A can solve it with a probability of 1/2. And B can solve it with a probability of 1/3. And C can solve it with a probability of 1/4. C can solve it with a probability of 1/4. What is the probability that at least one can solve it? At least one can solve it. One can solve it. At least one can solve it. It is just like your BTech project. Project will be given to a group of students, 3 or 4 students. Normally, in general, only one will do that project, the remaining will copy it. Okay, the remaining will copy it. Here, the important thing is all the three, if the result is good, all the three will get the same marks. Whether A has done it, or B has done it, or C has done it, all the three will be given same marks. Sometimes A and B may do the problem or that project. Sometimes B and C may do the project. Sometimes A and C or all the three may solve that project. Okay. So the thing is, you need to get the result of the project, or you need to get the solution for that given problem. A problem in mechanics is given to three students, A, B, C. A individually can solve it with probability 1 by 2. B individually can solve it with probability 1 by 3. And C individually can solve it with probability 1 by 4. Okay. So their individual probabilities are given like this. So here we are having P of A equals to 1 by 2. And P of B equals to 1 by 3. And P of C equals to 1 by 4. That is the thing given. At least one can solve it means, yesterday I had given you a results. Among those results, you can say the required probability. At least one can means the required probability. Required probability is equal to, at least one can solve it with 1 minus, none can solve it. None can solve it. So 1 minus A cannot solve and B cannot solve and C cannot solve. 1 minus A cannot solve, B cannot solve, and C cannot solve. This will gives you none can solve it. 1 minus none can solve it. 1 minus none can solve it. Okay. So you are having this data. So this is the required probability. 1 minus none can solve it means either A can solve, or B can solve, or C can solve, or AB, or BC, or AC, or all the three together, ABC, or all the three together, ABC. Is it okay? Somebody please respond.
Okay, sir.
Respond please. Yes. Now you tell me the answer. This is an important application that all the companies, okay, all the companies are following or applying for their business. Yes, what is the answer? Three by four. That's good. CMR 1 minus P of A complement means P of A by 2. P of A complement is 1 minus 1 by 2. And whenever unsounds multiplication, P of B complement is 1 minus 1 by 3. P of C complement is 1 minus 1 by 4. 1 minus 1 by 4. So this is equals to 1 minus 1 by 2 into, this is 2 by 3, this is 3 by 4. So this gets cancelled, 1 minus 1 by 4, 3 by 4. Everybody got it? Yes. Now let me explain. If a project is given to one student, it can be solved with probability 1 by 2. That means A can solve with 50% success rate and B can solve it with 33.3% success rate. C can solve it with 25% success rate. Say yes or no? A can solve it with 50% success rate, B can solve it with 33.3% success rate, C can solve it with 25% success rate. Okay. If the project is given to all the three cumulatively, you are going to get, what is the success rate now? 3 by 4 means 75%. Is it okay? Is it okay or not? Any doubt? Any doubt? Okay. Let me go for next problem, which was given again in the GATE examination. See, all these types were asked in the previous GATE examinations. An unbiased coin is tossed continuously. An unbiased coin is tossed. An unbiased coin is tossed continuously till the head turns up. 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 What is the probability? What is the probability that the head will occur? That the head will occur. That the head will occur. Head will occur in odd number of trials. Odd number of trials. In odd number of trials. Odd number of trials. Odd number of trials. So you want me to repeat the question? Anybody want to repeat the question? Say yes or no. Right. An unbiased coin is given. It is tossed continuously. Yeah, somebody are asking to repeat the question. Please write it. An unbiased coin is tossed continuously. An unbiased coin is tossed continuously. Continuously. An unbiased coin is tossed continuously till the head turns up. Till the head turns up. What is the probability that the head will occur? Head will occur in odd number of tries. Head will occur in odd number of tries. Coin is fair coin or unbiased coin. Unbiased. Already I explained. Fair or unbiased means you may get either head or tail. Equal chances of occurrence. So in this case, probability of getting head is 1/2, and probability of getting tail is 1/2. Now, if it is unbiased coin or fair coin, probability of getting head is 1/2, and probability of getting tail is 1/2. 1/2. Okay. It is tossed continuously till you get head. Our aim is to get head. Okay. So head will occur in odd number of tries. Odd number of tries. TRILS. Don't write TRAILS. Trail is different. Trial is different. Trial means toss. Trial means toss. Odd number of tries. That means you may get for the first time or third time or fifth time or so on. Please note it. You may get head. You may get head for the first time or third time or fifth time. And so on. Till you are getting head, we are tossing the coin. Till you are getting head, you are tossing the coin. So the required probability is first time head. First time head means the value is 1/2. R means plus. R means plus. Third time head means first time tail and second time tail, and third time you are supposed to get head. Do remember, first time tail and second time tail and third time you are supposed to get head. Okay, that means first time the value is 1 by 2 and means multiplication. Second time again the value is 1 by 2 and means multiplication. Third time you are getting head means again 1 by 2. That's it for third time. Odd number of chances, odd number of tries. R means plus. Plus. Fifth time means first time tail and second time tail and third time tail and fourth time tail and fifth time head. Again, R means plus, so on. So for this, 1 by 2 and means multiplication. Again, for this, 1 by 2 and means multiplication. Third time tail means 1 by 2 and means multiplication. Fourth time tail means 1 by 2 and means multiplication. So fifth time head, it is also having the same 1 by 2. 1 by 2. So on. So on. Now I think yesterday we did a calculation related to this. Please tell me the answer quick. Make it fast. Tell me the answer quick. Make it fast. Anyone can say the answer? Yes, 2 by 3. What kind of series it is? Even yesterday I had given the same kind of thing. But again, I want to say it because it is important. This was given in the previous game. It is an infinite geometric progression. Infinite geometric progression with initial term a equals to 1 by 2. Initial term a equals to 1 by 2. And common ratio r equals to second term by first one is common ratio. And again, third term by second one, or fourth by third term. What is that common ratio? 1 by 4. 1 by 4. So the required value is equal to a by 1 minus r. Even in aptitude also, you will be having this kind of problem. Here r is strictly less than 1 number. If R is less than 1, then you can write this kind of series, infinite. Series summation will be A by 1 minus R. If R is greater than 1, can somebody say what will be the value? If R is greater than 1, what is the sum of that infinite geometric progression? Can somebody say please, quick? No answer. See, very simple. You cannot use this formula. If R is greater than 1, I am saying, I am asking you, if R is greater than 1, common ratio is greater than 1, it will be increased, infinite series. Okay, some A plus some value greater than 1, some value greater than 1. Keep on multiplying it, you will be having infinity. The sum of that infinite geometric progression value will be infinity if R is greater than 1. If R is less than 1, we are using this formula, A by 1 minus R. So A is now 1 by 2 by 1 minus 1 by 4. So the answer is 2 by 3. Answer is 2 by 3. Is it clear? Is it clear? Everybody got it? Everybody got it? Say yes or no. Yes, that's good. That's good. Right, the next one, which is very important, you may use it in the casinos. But it is not like that. But in gambling, you can apply that theory. But that is also important. I said yesterday that it is called as Huygens problem. Huygens. Huygen apostrophe S. Huygens problem. Huygens. Huygen. HUY. PN apostrophe S. Huygens problem. Is it okay? Write down. Capital A, comma, capital B. Capital A, comma, capital B. Throws a pair of pair dices. A pair of pair dices. A pair of pair dices. On the understanding that A wins if he gets 7 points. If he gets 7 points. 7 points. B wins if he gets. B wins if he gets B wins if he get 6 points. B wins if he get 6 points. 6 points. What you have done, A and B throws a pair of 8 dice. Please include this one successively. Successively. That means first A is throwing, next B, and then next A, next B, next A, next B. One after the other. That is the meaning of successively. Okay. Not both throwing pair of dice at the same time. They are throwing the dice successively. So on the understanding that A wins if you get 7 points. B wins if you get 6 points. If A has started the game, if A has started the game, if A has started the game, find their respective chances of winning. Find their respective chances of winning. Find their respective chances of winning. Amma, in the last problem in a head and tail game, we have discussed A and B both have chosen same favorable thing. Both have chosen head. Yesterday's last problem. A has chosen head, B has chosen head. And success of getting head is 1/2. For B also 1/2. Both are having same favorable things. But here for A it is 7 points. For B it is 6 points. For B it is 6 points. Now here you need to understand when you are getting 7 points, when you are getting 6 points. When a pair of dice were thrown, what are the total exhaustive events? When a pair of dice were thrown, what are the total exhaustive events? 1, 1, 1, 2, up to so on, 1, 6, 2, 1, 2, 2, up to so on, 2, 6, and so on, 6, 1, 6, 2, up to so on, 6, 6. How many are there? Please speak out. Tell me how many exhaustive events are there? Can somebody write it? How many are there? Count it. 1, 2, 3, up to so on 6, 7,
36.
8, 9, up to so on. Totally 36. Totally 36. Say yes or no? Say yes or no. Now 7 points you will get if it is 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, and 6, 1. How many? Total is 6. So probability of getting probability of getting 7 points is equal to 6 by 36. Nothing but 1 by 6. And the probability of not getting 7 points is equal to not getting 7 points makes 1 minus 1 by 6. 5 by 6. Please note down. Again, you will have 6 points. If score is 1, 5, 2, 4, 3, 3, 4, 2, 5, 1. How many times? Totally 5 times. So probability of getting 6 points equals to 5 by 36. And probability of not getting 6 points is equal to 1 minus 5 by 36. That is 31 by 36. Please note down, everybody note down. This is important data. This data we are going to utilize it now for the required probability. In the previous problem, we have considered A and B both having same chances, that is getting head. But here A favorable things are different, B favorable things are different. Is it okay? Say yes or no. Yes, please. Say yes or no. Is it okay? Now, who started the game? If A has started the game, are you getting my voice? Now, is it okay?
Yes, sir.
Yes. Now, A has started the game. Please write it. Please write it. Quick. A has started the game. So, A may get 7 points. A may get 7 points in first or third or fifth or so on. or so on chances or throws. A may get 7 points. I'm erasing this data. So you have to remember this data. Okay. Now A may get 7 points in first or third or fifth or so on. A may get 7 points. 7 points in first chance or third chance or fifth chance or so on. Okay. So probability that A wins is equal to first time A should get 7. Okay. What is this value? A is getting 7. What is the value? What is the value of A getting 7? You are having in your notes. What is the value of A getting 7? Yes. 1/6. 1/6 or not? R means plus. Third time means A wins in third time means in first time A should not get 7. A not 7. And second time B should not get 6. And third time A must get 7. Third time A must get 7. So A not 7 means 5/6 and means multiplication. B not 6 means B not 6. B not 6 means 31/36. 31/36 and A must get 7 means A must get 7 means sir, speak out. A must get 7 means one of you please speak out. Tell me quick. 1/6. 1/6. A may get 7 points for the first time with 1/6 or plus third time A is getting 7 means first 2 times what happened? You should write. The third chance will arise if the first one A started the game. First one A not 7 and second time B not 6 and third time if A wants to get 7 points or A wants to win, A should get 7 points. R means plus. Plus. Next, fifth chance. First time A not 7 and second time B not 6 and third time A not 7 and fourth time B not 6 and fifth time A must get 7. So what is this? A not 7 5/6 and means multiplication. B not 6 31/36 and means multiplication. A not 7 5 by 6. B naught 6, 31 by 36. And A7, 1 by 6. R is plus and so on. Now, did you understand? Have you got it? Did you understand? Have you got it? Sorry, please respond. Have you written or not? Yes. Good. Now tell me the answer. There is a matter. If you got it, then you have to do it. This is also infinite series. And again, second term by first, third term by second. Both are having same common ratio. So you were right. Is an infinite geometric progression with initial term a equals to 1 by 6, common ratio r equals to 5 by 6 into 31 by 36. And r is less than 1. So the answer for this will be a by 1 minus r. Please tell me the answer. Make it quick fast. Yes, what is the value? What is the value? It's a matter of few seconds. That's enough. A is 1 by 6. 1 minus r. R is 5 by 6 into 31 by 36. If you do simplify, 6 into 36. 1 by 6 by 216 minus 155 by 6 into 36. This 6 gets cancelled. Yes, what is the answer? What is the value of B not getting 6? What is the value of B not getting 6? Oh. What is the value of B not getting 6? What is the value of B getting 6? 5 by 36. Five by 36. Say yes or no? No. Everybody are just. If everybody are kept quiet, then what is yes, B not getting 6 is 5 by B getting 6 is 5 by 36. B not getting 6 will be B not getting 6 will be 31 by 36. Okay. Then you just keep on writing this. Initial term is 6 by 36, that is 1 by 6. If you do simplify, yes. What is the answer? Tell me the final answer. 36 by 61. Everybody got this? Everybody got this? Say yes or no. No response. In the same question, for the same data, you please write another question. For the same data, you do it. You do the calculation, no problem. It is finished. Okay. Here, you please write another question for the same data. If B has started the game, if capital B has started the game, if capital B has started the game, what is the probability? What is the probability that A wins and B wins? What is the probability that A wins and B wins? So you tell me now, who started the game? Come on, speak out. Who started the game? For the same data, I am saying different question. Who started the game? B has started the game. If B has started the game, Write down. If B has started the game, if B has started the game, if B has started the game, probability that A wins, probability that A wins, A wins, A wins will be in first or sorry, in what chances that A will wins? Who started the game? Who started the game, sir? Who started the game? B has started the game. B has started the game. So then A wins in what chances? A wins in what chances? Again the same. A wins in. A wins in. Amma, second time because B has started the game. And fourth time because A has started, B has started the game. And the sixth time. Okay, write down. A wins in. If B has started, if B has started, then A wins. A second or fourth or sixth, so on. Second time means first time 306 and B has started. Second time A7. Fourth time means first time B06 and second time A07 and third time B06 and fourth time A must get 7. So B06 is 31 by 36 and makes multiplication. A7 means 1 by 6 R plus B06 is 31 by 36 and makes multiplication. This is A07 5 by 6 and makes multiplication. B06 is 31 by 36 and makes multiplication. A7 is 1 by 6. R means plus. So on. This is also infinite geometric progression with initial term A equal to 31 by 36 into 1 by 6. Common ratio R equals to, what is common ratio? 5 by 6 into 31 by 36. Now the value will be Since it is an infinite geometric progression, A by 1 minus R. So this is 31 by 36 into 6 divided by 1 minus 5 by 6 into 31 by 36. Thirty-one by 36. If you do simplify, the answer will be 31 by 61. 31 by 61. Now same thing. Taking LCM, 36 into 6, both gets cancelled. 31 by 36 into 6 is 216 minus 155. 31 by 61. Who started the game? Who started the game? Here B started the game. Even B started the game. A is having more chances of winning. Because 31 out of 61. And probability in this case, probability of B wins is 30 by 61. So A is having more chances because A has more favorable things. 7, the sum of the points, 7 occurs. 7 occurs 6 times. 6 occurs 5 times only. So A has chosen more favorable things than that of B. A has chosen more favorable things than that of B. That's why A is having more chances of winning. Whether A starts the game or B starts the game, the one who chosen more favorable things will have more chances of winning. Please write as a note. That difference I want to show it with this problem. In the previous case, A started and A is having more chances, 36 by 61. Out of 61, 36 times it will win. But even B has started, A is having 31 chances out of 61. Even B has started, A has more chance of winning than that of B. Please write a note. Please write a note. Since A has chosen more favorable things, since A has chosen more favorable things, A have more chances of winning. A have more chance of winning. More chances of winning. A have more chances of winning. Whether A starts the game or B starts the game. Whether A starts or B starts the game. But in head and tail game, A and B have chosen same favorable things. Head. That's why the one who starts the game will have more chances of winning. But here, the one who chosen more favorable things will have more chances of winning. More chances of winning. Is it clear? Is it clear? Say yes or no. Somebody write. Right. Let us go ahead with the dependent event problems, 1 or 2, which were given in the gate. Then we will discuss Bayes' theorem, which is very important. Write down problems on dependent events. Dependent events. Write down. In a housing society, there are equal number of men and women. There are equal number of men and women. Of men, 50% are employed. Are employed. 50% are employed. And of women, 20% are employed. 20% are employed. 20% are employed. A person is selected at random. What is the probability? That the selected person is unemployed? What is the probability that the selected person is unemployed? Everyone have a double question? So if you have doubts in the question, I'll repeat it. I'm explaining again. I'm noting the data on the board. There are men and women. Okay. Probability of getting men is 50%. 50 by 100. And probability of getting women is 50%. 50 by 100. Equal number of men and women. Now, probability of getting employed from men. Is 50%. Employed from men. 50 by 100. And unemployed from women. Unemployed means E bar. Unemployed, E bar. Or you may write unemployed, 2E from men. If it is 50% employed, 50% unemployed from men. 50 by 100 men. First you have to choose men and then unemployed or employed, whatever it may be. Next, we have employed from women. 20%, 20 by 100. Employed from women is 20%, 20 by 100. Probability of unemployed from women is 20% employed means remaining 80% unemployed. 80 by 100. So we need to get, ultimately we need to get a person who is employed or unemployed. What you have written? Please somebody write it. What you have written in the question? What you have written? Is it employed or unemployed? No response. Employed or unemployed? Probability of getting unemployed, whether it is from men or women, is equal to, first you have to choose men and here ultimately we need to get unemployed. That means men and unemployed. Women and unemployed. You need to get a person who is unemployed. There ends the matter. You need to get a person who is unemployed. Unemployed means he may be either from men or women. Okay. So first you have to choose men and unemployed from men. Dependent events. Among the men, there are two types, employees and unemployed. Here, unemployment is depending on men. Again, unemployment is depending on women. The unemployment in men is less than that of unemployment in women. Or unemployment in women is more than that of unemployment in men. Say yes or no. Now the required probability of getting unemployed is equal to probability of getting men and means multiplication. Probability of getting men from unemployed. R means plus. Men, sorry. We need to get unemployed from men. Unemployed from men. First you need to get men. Choose all the men and among those men, choose unemployed. R for R. Choose women and multiplication probability of getting unemployed from women. Please write the answer. Probability of getting men is 1 by 2. Unemployed from men is again 1 by 2. R plus probability of getting women is 1 by 2. And probability of getting unemployed from women is 80 by 100. That is 4 by 5. Tell me the answer. 1 by 4 plus 2 gets cancelled. 2 by 5. So the value is 4 5 20 and 5 plus 5 4. 4 to 8. 13 by 20. 13 by 20. Any change here or any doubt? Any change or any doubt here?
షెడ్యూల్ వేశారు అక్కడ డైలీ క్లాసెస్ ఉంటాయి హెచ్ఓడిస్ ఏమో ఎగ్జామ్స్ అవి లింక్స్ అవి ప్రిపేర్ చేశారు ఎవ్రీడే
Yes, yes.
అంటే గేట్ ఫ్యాకల్టీ దగ్గర నుంచి అక్క పే చేశారు
ఏమ్మా?
సార్ వాళ్ళ దగ్గర నుంచి.
ఏంటి what is your problem? Somebody are speaking. Yes, what's the problem? Yes, Amma, what is the doubt? Somebody please write or speak out. Somebody start, please.
ఫుల్ వర్క్స్ హెచ్ఓడి కూడా వేస్తుంది సార్ అక్క ఇంకా ప్రాజెక్ట్ నుంచి ఏం లో దూరద్దన్నారు అక్క ప్రతిసారి గేట్ వాళ్ళ
No one is responding. Yes, any doubt? You are asking me to explain the gate problem. You are saying that it is not a gate problem. Yes, sir. Any doubt? Any doubt?
No, sir.
Then somebody respond. What is the answer? Is it the same answer? At least one of you have to do the calculation and tell me that whether it is correct or not.
Sir, correct, sir. 13 by 20, sir.
Yes,
13 by 20, sir.
13 by 20. Is it okay?
Okay, sir.
Right. So 13 by 20 means if you multiply with 5, 65% of total people, men and women, 65% are unemployed. Okay, please write that finally. Totally 65%, whether they are men or women. Totally there are 65% of unemployed are there. 65% of unemployed. Right, one more problem related to this which was given in the previous gate and for several times it was asked. Several times it was asked. Please note down. There are 2 papers in an examination. There are 2 papers. 2 papers in an examination. 2 papers in an examination. The probability of failing in paper 1 is The probability of failing in paper 1 is 0.3. The probability of failing in paper 1 is 0.3. And the probability of failing in paper 2 is probability of failing in paper 2 is 0.2, 0.2, 0.2. Given that a student has failed in paper 2, just put the symbol comma. Don't write COMA or CAMA. Put the symbol comma. Given that a student has failed in paper 2. A student has failed in paper 2. Paper 2. Then what is the probability? Sorry. Given that a student has failed in paper 2, put the symbol comma. Then the probability of failing in paper 1 is. Then the probability of failing in paper 1 is. Then the probability of failing in paper 1 is 0.6, 0.6, 0.6. Then what is the probability? Then what is the probability? What is the probability that the student has failed? That the student has failed in both the papers. What is the probability that the student has failed in both the papers? In both the papers. In both the papers. I'm giving you the options. Options are very important here because you may get confused while writing the answer for this. This sort of questions will be asked, were asked and previously asked. Okay, I'm giving you the options. Option A, 0.06. Option B, 0.18. Option C, 0.12. Option D, 0.5. Please note down these options quick. I repeat the question. There are two papers in an examination, paper 1 and paper 2. The probability of failing in paper 1 is 0.3. And the probability of failing in paper 2 is 0.2. Given that student has already failed in paper 2, comma, then the probability of failing in paper 1 is 0.6. Then what is the probability? What is the probability that the student has failed in both the papers? The student has failed in both the papers. Okay? Everybody have written the question clearly? Somebody may respond. So as per the data, probability of failing in paper 1 is 0.3. And probability of failing in paper 2 is 0.2. Given that student has already failed in paper 2. Paper 2. Okay, given that student has already failed in paper 2, then the probability of failing in paper 1 is probability of P1 given P2 is given as 0.6. Given as 0.6. Okay. See, let me explain this kind of situation. Previously, in BTech, long back, I think 30 or 40 years back, if P1 is the theory exam, P2 is the lab exam. If a student failed in lab will be conducted first. If a student failed in lab, he will be declared he failed in paper 1 also. That P1 be theory, P2 be lab. Previously, there is a link in between them. If a student passed in theory, failed in lab, then he will be declared that he has to, he failed in both theory and lab. So, this lab examination result affects the theory result. Even if he passed the theory exam, if he failed in lab, he will be declared he failed in theory also. So the lab examination RP2 result affects the passing of theory. The P2 result affects passing of P1. So here P2 affects P1. So P1 and P2 are two different examinations, but P2 affects P1. So therefore P1 and P2 are dependent events. Please write. This is important. This is important. Here P2 affects paper 2 result affects paper 1 result. Okay. Paper 1 is individually he fails with 0.3. Paper 2 individually fails with 0.2. Lab conducted first. Given that he failed already in P2, then the probability of failing in P1 is, because of the effect of this lab, the probability of failing in P1 is increased. Individually, it is only 0.3. Now it is increased to 0.6. The probability of failing in paper 1, when he already failed in paper 2, is 0.6. So P2 affects P1. So therefore, P1 and P2 are dependent events. Please write that. P2 affects P1. Therefore, P1 and P2 are dependent events. So you have to write probability of failing in P1 when he already failed in P2 as 0.6. As 0.6. Is it clear? Is it clear? Please respond, somebody. Then if you are understanding the problem, writing answer is less than a minute, less than 30 seconds. Somebody please write it. Is it clear or not? No response. The question asked is probability of failing in first P2 and P1. Okay, in both the papers, both means P1 and P2 or P2 and P1. P1 and P2 or P2 and P1. Probability of failing in both the papers. Please write. Probability of failing in both the papers. PR means probability. Probability of failing in both the papers. P1 and P2 is P2 intersection P1 is equal to first he failed in paper 2 and whenever intersection and probability of failing in paper 1 and he already failed in paper 2. Then you can write the answer. I think no need of explaining the calculation. You can say the answer. Please tell quick. If you people are having the doubt, you can ask me a
0.12, sir.
quick explanation. If you are having the doubt, you can ask me and repeat the explanation. Tell me the answer quick.
Zero point 0.12, sir.
So what is the answer? 0.12. That's good. See, if you are writing 0.3 into 0.6, the answer will be 0.18. If you are writing 0.3 into 0.2, the answer will be 0.06. So there are a lot of confusion among the options. That's why if you understood the problem, then you can write the answer very easily. This was asked in several competitive examination, including the GATE examination. Including in the GATE, it also several times it was asked. Same type of problem. Writing answer is simple. You have to understand the concept behind it. Now write down Bayes theorem. Everybody finished? Everybody finished? Say yes or no? Yes or no? Quick. No response. Yes or no? Right. Write down Bayes' theorem. We'll explain. I'll explain that statement now. We'll continue the problems in the next class. Write down Bayes' theorem. Bayes' theorem. Make it quick fast. Bayes' theorem. Write down. See, let me explain first and then you can take the notes. If there are n number of exhaustive events, if you are having n number of boxes, B1, B2, so on, Bn, n number of boxes. Okay, let me explain along with an example. Box 1 is having some 5 balls, box 2 having some 6 balls, box n is having some 100 balls. Okay, let A be the event of corresponding to the balls in those boxes. A be the event of corresponding to the balls in those boxes. Okay. Now these boxes B1, B2, so on, Bn, they can be chosen with the probability of P of Bi for I equals to 1, 2, 3, so on, n. Okay. We have given some 10 boxes. Box 1, box 2, box 3, and so on. They can be chosen with the probability P of Bi. Box 1 can be chosen P of B1, box 2 can be chosen P of B2, and that data will be given in the problem. A be the event corresponding to the balls in those boxes. Now the probability that A is having different number of balls are different related with those boxes. Now the probability of happening of that ball or choosing a ball from that particular box is P of A from Bi, given Bi. Suppose if B1 is having 5 balls, B1 I have taken. Now choosing the ball from that first box is P of A given B1. Choosing a ball from second box, P of A given B2. Choosing a ball from nth box, P of A given Bn. Okay, so that is the probability of choosing a particular event from those boxes. Now randomly means close your eyes. Not now, don't practice it. Okay, close your eyes means you just visualize yourself or think about yourself. You are having 10 boxes, close your eyes. You have taken a ball from one of those boxes. You have taken a ball. Ball means event A. From one of those boxes, we don't know from which box you have taken. Then the probability that the ball belongs to ith box is written as P of Bi given A. First taking box and then taking ball is P of A given Bi. Taking box with probability P of Bi and taking ball from that particular box is P of A given Bn. Now I have closed my eyes Okay, I have chosen a ball. From which box I have chosen, I don't know. From which box I have chosen, I don't know. I have chosen a ball. From which box I have chosen, I don't know. Now you are expecting, you are finding the probability or the possibility that the ball belongs to first box, that the ball belongs to second box, that the ball belongs to third box. That estimation, that probability, that chance of finding or belonging that particular ball belongs to that particular box is P of Pi given A. P of Pi given A. Okay, that you have to estimate. Now, what are number of exhaustive events? We have B1, B2 up to so on Bn, and then ball from that particular box. That means whenever probability comes out, or whenever we are discussing the probability, number of favorable events divided by number of exhaustive events. Okay, what are exhaustive events? You have to choose first box and ball from first box. I have chosen first box and ball from first box R plus. I have chosen second box and ball from second box. Ball from second box R plus 1 plus. I have chosen nth box and ball chosen from nth box. Okay, these are all exhaustive events. All possible outcomes in the experiment. First box and ball from first box, or second box, ball from second box, or third box and ball from third box, or continue this so on. Nth box and ball from nth box. These are all possible outcomes. What is favorable? Probability of choosing ith box, and ith box may be first or second or third. You have only one favorable. If two are favorable, you can make two. Probability of choosing first box, ith box, and probability of choosing ball from ith box. Ball from ith box. Favorable divided by all outcomes in the experiment. This you may write it as P of Pi into P of A given Bi divided by summation I equal to 1 to n. I equal to 1 to n. P of Pi into P of A given Pi. P of A given Pi. This is known as Bayes' theorem or theorem of inverse probability. This is known as Bayes' theorem or theorem of inverse probability. Why inverse? If you take a box and then ball from it, that is direct probability. Okay. You will be knowing taking box and then ball from it. That is direct. Why I am saying inverse? You don't know from which box you have taken this ball. Randomly you have taken a ball, or somebody have taken a ball and given it to you. Now you have to estimate, or you need to find the probability or the chance that the ball belong to ith box, that the ball belong to first or second box or third box or fourth box or nth box. Is it clear? That's why we call it as theorem of inverse probability. Theorem of inverse probability. Is it clear?
Yes, sir.
Yes. Write down now. Make it quick. Write down the statement. Consider ఏం చదువుతున్నాడు ఏం చదువు ఏంటి చెప్పాలి పెట్టాను ఓకే you may go. Consider n number of exhaustive events. N number of exhaustive events. N number of exhaustive events. B1, B2, so on, Bn. B1, B2, so on, Bn. With its happening probability. P of Bi. With its happening probability P of Bi. For I equals to 1, 2, 3, so on n. For I equals to 1, 2, 3, so on n. I equal to 1, 2, 3, so on n. And let capital A be an event. Let capital A be an event. Capital A be an event corresponding to the given exhaustive events. Corresponding to the given exhaustive events. With its happening probability. P of A given Bi. A given Bi. Don't say A by. P of A given Bi. P of A given Bi. Then P of Bi given A equals to P of Bi given A equals to P of Bi into P of A given Bi by P of B1 into P of A given B1 plus P of B2 into P of A given B2 plus so on P of Bn into P of A given Bn. P of A given Bn. That equals to P of Bi into P of A given Bi by summation or sigma I equals to 1 to n P of Bi into P of A given Bi. P of Bi into P of A given Bi. P of A given Bi. This is known as Bayes theorem. Bayes theorem or theorem of inverse probability. Bayes theorem or theorem of inverse probability. Theorem of inverse probability. Normally, in any of the textbooks or the materials, you might be finding only that equals to this. This explanation you will be missing. If you are missing this explanation, you cannot understand the problem. If you don't understand the problem, then it is not possible to write the answer to that. And while any question is given, the most important thing is you have to observe whether they are dependent events or not. The previous two problems we have discussed whether they are dependent events or not. Okay. Paper 2 affects the failing probability of paper 1 in the last one. And before that, employment, unemployment of men is different, unemployment of women is different. So they are dependent events. You have to observe this given problem whether the events are dependent or independent. Is it clear? We will discuss the problems based on it if it is possible tomorrow or in the next class. So these are very important. Okay. So next we are having some small topics, discrete and as well as continuous random variate, and then distributions. Among those, binomial, Poisson, normal, uniform distribution. Just binomial and Poisson you can expect. Binomial several times. Okay, all these are simple things. And then a few definitions along with coefficient of variation. That finishes the probability and as well as statistics. Okay, actually this finishes the probability. And then statistics will be of very simple small topics. That's it. That we will continue in the next class. Is it okay? Any doubts? Say yes or no. Somebody respond. Yes. Is it clear? If it is possible, tomorrow we'll continue the class. Then it will be far better. Okay, then you can take leave.
Thank you, sir. Good night.
Good night. Bye. బాగానే కనబడుతుంది రా. ఏం డౌట్స్ ఉన్నాయా?